if we go back to the functional design, then basically what you describe is the kind of functions that you want. Now there's only just a few functions. For instance, we want to generate sounds, and we want to process them. We want to mix. Oops, sorry. We want to mix them, and then we want to record them. But most probably you would do the recording on a separate device. But this is basically sort of the kind of general functions that you want. Of course, if you want to generate sounds, then there's several ways to go about. So you might have different kind of generators. If you want to process sound, there's different kind of processors. And if you want to mix, there's different kind of ways of mixing sounds. And that is basically sort of what you would like to find back in your functional design. And of course, the idea is that if you make this design, you try to get a well-balanced set of functions that together sort of give you the idea of an instrument and not just of a device, because you want to play with the thing. And at this moment, we see this enormous surge of Eurorack modules, which I think there's almost like 1,500 different kind of modules from different brands that you can buy, which is a staggering amount. But I also see that many people that assemble Eurorack systems, they're not really very aware of this idea that what you would really want is a well-balanced set of functions. Because only a well-balanced set of functions will actually turn it into an instrument. And I see them change their setups constantly because I need another oscillator. Oh, I have already 5 envelope generators, I can remove some of those. Then my question is, how did those 5 envelope generators get there in the first place? Why not 2 or something like that? So I actually decided not to be active in this market and only produce one particular kind of module, but more concentrate on trying to create complete instruments that are perceived as an instrument. So for me, this idea of making a good functional design is quite important, because I really would like to have a well-balanced mix. And it's difficult to do this. It's not really that easy. It is a sort of, well, you also need a bit of gut feeling for this. It's not that you can sort of, because there's so many different kinds of music these days. You cannot cater for everyone. And if you would like to, you would end up with much too big a system that is much too expensive and that is definitely not portable, etc., etc. So then you don't really succeed. So the balance between sort of a flexible, interesting system that can do a lot, but by the definition, not all. Well, it's a nice puzzle. It's a nice puzzle, but I like to do those kind of puzzles. So now, if you have a nice functional design, then the level that is next to that functional design, I actually call it the algorithmic level. Because for every function, it is important to find a proper algorithm that does exactly what it is supposed to do, and that is also of the quality that you need. Now, an algorithm is very simply The definition of an algorithm is sort of like a very efficient way to do something, or preferably the most efficient way to do something. And an algorithm, so basically an algorithm, it's not like a mathematical function, because an algorithm can use mathematical functions, and it's very often applied to mathematics, but it can also describe a procedure to do something. So it is, maybe it seems a bit vague, but it is actually of crucial importance. Because at the algorithmic level, you actually define the final quality of your system. What the algorithms do is they will process sound waves. They will not process, so basically they will do computations. And computations is, with computations, people also these days think about digital computers. But computations basically are, can also be performed by humans, or they can be performed with analog circuitry. So there are also analog computers. If you Google analog computer, you will find some pictures of devices mostly around the year 1960 that suspiciously look like modular synthesizers. And I know two old analog computers in the Netherlands. A good friend of mine who has a studio in the south of the Netherlands, it's called the Toonzaal. He has built a studio with all this old 1950s and 60s tube stuff of Hewlett-Packard and Brüel and Kjaer, and he also has this old analog, I think it's a Hitachi, I'm not sure about it, old analog computer that is integrated in the studio, and you can actually patch up an oscillator or patch up a filter and patch up that kind of things and integrate it in your sound processing. So I also build small analog computers to basically do this. So these are not really modules. Well, they are modules, but it's actually more accurate to say that they are all little analog computers, and all these little analog computers, they perform a specific algorithm. For instance, an algorithm to produce a sound wave, an algorithm to filter a sound wave, an algorithm to manipulate some property of a sound wave. And they actually use sort of mathematical formulas to do that. So it's very important. Of course, if you're into using computers for sound synthesis, it is much more common to think in terms of algorithms, and you have algorithms with names, like you have the Kapler-Strong algorithm that can produce the sound of a plucked string, and there's even a company, Yamaha, that sort of made a synthesizer that said, we have algorithms and you can use algorithm 7 to create an electric piano sound or something. You also, of course, have physical modeling, where algorithms basically try to recreate basically you make a model of an existing acoustic instrument, a mathematical model, and try to come up with an algorithm that can very efficiently sort of execute the computations needed to hopefully produce exactly the sound that the acoustic instrument would do. So that is very important. So if you have a list of if you have described your conceptual design, you have described your functional design, you have found and developed the proper algorithms to implement that, then you can actually sort of go and build the physical thing. And for that, I would say that is not really of much interest, because that means that if you make an electronic device, you would make a electronic schematic with chips and components and stuff, and then finally sort of produce PCBs and make little holes in the PCB so you can mount the components, solder them together, screw them behind the front panel, and there's your machine. And everything that comes below this level I just call production files. That's where the blood, sweat and tears really go. But this is for me always the most interesting.